Okay, Math 708 Geometry Study Guide, problem number 1. Which two rays form angle ACB? ACB here. I've already started the study guide. I marked the two rays CA, starting at C and going out. This ray would be part of ACB, and angles and line ray CB would be part of angle ACB. Try to trick you with AC, but you don't start outside. You start from the vertex and then you go out. So you start at C and then you go to A. Problem number 1. Okay, problem number 2. What type of angle is ACB? ACB, you have the option of a right angle, which is a 90-degree angle, usually identified by the little box in the corner. And right angles are perpendicular lines. They're going opposite directions. An acute angle, I remember acute meaning small. So acute angles are less than 90 degrees. There's an obtuse angle, ob maybe meaning obese because it's big. Greater than 90 degrees, that's what maybe help me remember obtuse as greater. And then straight angles are just straight lines, and they total 180 degrees. So ACB is lining up with an obtuse angle. It's greater than 90 degrees. So you turn that greater. Okay, moving on to number 3. Which type of angles are angle 5 and angle 8? And I already have the answer for that one, but let's go over that real quick. Complementary angles are two angles that total 90 degrees. Doesn't matter if it's 45, 45, 50, 40, whatever totals 90 degrees, they're complementary. Okay, supplementary angles are two angles that total 180 degrees. It could be 20 and 160. It could be 90 and 90. As long as it totals 180, it's a supplementary angle. Vertical angles are across from each other. They kind of like, when you make the arcs, they kind of resemble like a hourglass look. This looks like an hourglass to me, and that's what vertical angles look like. They are also equal. Vertical angles will equal each other. So if this is 30, this is 30, 50, 50, whatever this is, the vertical angle will be the same. And then you have corresponding angles, which are also equal angles. But for corresponding angles, you always have two lines, and then this line that intersects the two lines. This line creates 4 angles here and 4 angles here. If I made arcs all the way around, you would see there's 4 angles. And the corresponding angles, take either set, place it on top of the other set, and wherever they line up, that will be the corresponding angle. So if I took this set and laid it on top of this set, these 20s would line up with each other, so they're corresponding. And then these would be corresponding, and then these would be corresponding, and so on. Okay? So, knowing that 5 and 8, they kind of make an hourglass look. They are vertical angles. Okay, problem number 4. What is the measure of angle 7 in this picture right here? Okay, angle 7 is right here. We know that angle 2 is 120 degrees. Okay, we've got to figure out, is angle 7 equal to that, or is it supplementary to that? Let's see. Since 2 and 3 are vertical angles, they're equal. Then we can take these and line them up over here on top of these, and you'll see that they correspond with 2 and 3 correspond with 6 and 7, making these also 120 degrees. So that means angle 7 is 120 degrees, just like angle 2, because it is vertical to the corresponding angle of 2. Problem number 5. What is the measure of an interior angle in a regular octagon? This is a formula that you need to memorize. Okay? To find the sum of interior angles, this is the formula. n minus 2 times 180. N stands for number of sides. So this shape right here, how many sides does that octagon have? 8, right? Like an octopus has 8 legs. So we're going to take 8 minus 2, multiply it by 180, and then we also have to divide it by 8 because they're wanting to know just one of the interior angles, not all of the interior angles. So we have to divide it into 8 separate angles when we're done. Okay, so this becomes 6 times 180 over 8, which would then be 0, 48, I think it's 1,280. Let me double check that real quick. Well, 1,080, sorry. And then we'll have to divide that by 8. And I'll let you do that part, okay? This is the end. Now you find the answer. 1,080 divided by 8. That will give you one of the interior angles of a regular octagon, okay? Remember, you have to memorize this formula right here. This formula pops back up in number 6. What is the sum of the angle measures in a 26gon? Except we're looking for a sum now, which is total measures, so we're not going to have to divide by 26. Okay, so this is going to be a little quicker because we're just going to go 26 minus 2 times 180. A 26gon obviously has 26 sides. So then it's 24 times 180. And I'm also going to leave this for you to finish problem number 6. 24 times 180, that will give you the sum of the angle measures of a 26gon. Okay, problem number 7. AC is a diameter of circle D. If the measure of angle BDC is 140 degrees, what is the measure of arc AB? Well, let's look at the picture. They're wanting to know the measure of this arc right here. If you know that this is 140, what would this be? Well, we know a half circle is how many degrees? 180 degrees. So all we have to do is take 180 and subtract 140, and what we're left with would be arc AB. 40 and 140 together make 180. Okay? Problem number 8. Which of the following is a radius of circle D? A radius, remember, it doesn't go, this is the diameter, it goes all the way across. Radius will only go halfway. So DC is a radius, DB is a radius, DA is a radius, and you could also call it BD, yeah. Since we're not identifying a ray, you could say BD or DB there, okay? This would not be a radius, it's an arc. AC is a diameter, and AB connects these two points, so it's not a radius. Problem number 9. In a right triangle, the measure of one acute angle is 13 degrees. What is the measure of the other acute angle? So I drew this shape. It's not on your study guide, but I drew it. A triangle with a right angle. Remember, the box identifies the 90-degree angle. So we know this is 90. We know this is 13. We just have to figure out what is this. You should already know that the interior angles of a triangle always total 180 degrees. So you're going to subtract 90, then you're going to subtract 13, and what you're left with will be this remaining angle right here. Okay? So I'll let you figure that out for problem number 9 also. Okay, moving on to problem number 10. Select all that apply. In an isosceles triangle, one angle measures 10 degrees. What are the measures of the other two angles? Okay, so I drew, this is also not on the study guide, but I drew two triangles. Isosceles means at least two sides are equal, and also the base angles will be equal in an isosceles triangle. So if I were to put this angle as 10 degrees, then what would these two have to be? Remember, it has to total 180 degrees. So let's see, 180 minus 10 is 170. So divide 170 by 2, to split it up between these two angles right here. And 170 divided by 2 is 85. So these two angles have to be 85 degrees. And when you add all this up, you get 180 degrees. So it could be this answer. And then what happens if one of these angles are 10 degrees? And that means the other one is 10. So then what do we have up here? We're going to have to go 180 minus 10, 20. We're going to subtract 20, 160. So 180 minus 20 is 160. Okay, so this missing angle was 10, and this missing angle here would be 160. So it could be this answer also, not the other two. Okay, problem number 11. What is the measure of angle 1 in the rhombus? Rhombus? One of the rules about the rhombus is opposite angles are equal. So if this angle is 40, then we know this angle is 40. So since a rhombus has 4 sides, what is the total angle measure, interior angle measure of 4 side shapes, quadrilaterals? They have to total 360 degrees, okay? Remember, the triangle has to total 180, but the quadrilaterals have to total 360. So we're going to take 360 and we're going to subtract 40 and 40, which is 80, and we're going to get 280, right? And then we're going to divide 280 by 2 because we have to split it between these two angles right here. 280 divided by 2 is 140. So what is the measure of angle 1? Angle 1 would have to be 140. Okay? Problem number 12. What is the measure of angle 1 in this trapezoid? Okay. One of the rules about trapezoids is put a line down the middle like this. These two angles have to total 180, and these two angles have to total 180, making a total of 360. But in trapezoids, I can't remember the name. They're not adjacent. But the angles on the left have to total 180, and the angles on the right have to total 180. So all we have to do is take 180 and subtract 105. And what are we left with? 75, right? So angle 1 has to be 75 degrees in order for these two to total 180. All right, what is the perimeter of the larger of the two similar parallelograms? Okay, perimeter, we're missing a side. Remember when we have 3 numbers and we're missing the 4th, we can do a proportion. We're going to go 2 over 4 equals unknown over 6. And remember, we multiply and divide. So 6 times 2 is 12. 12 divided by 4 is 3. So the missing piece is 3. 2/4 and 3/6. Okay, so this is 3. Now we can find the perimeter easily because we know this is 3 and this is 6. You just have to add those 4 numbers up. Okay, which is 18. So this problem required finding that missing side with a proportion and then adding up your 4 sides for the perimeter. Problem number 14. Given ABCD is similar to EFGH, what is the measure of H? Okay. What angle does H correspond to on this shape? If you took this and you turned it to be the same as this, you would see that H corresponds to D. Since they correspond, they're equal. Similar shapes, the sides don't have to equal, but the angles will equal. So this 70 degrees, that means E would be 70 degrees. 116 degrees for B. F would be 116 degrees. So corresponding angles of similar shapes are equal. Okay? Problem number 15. How many lines of symmetry does this regular polygon have? Let's look at this regular polygon. Oh, I wrote the rule. there is a line of symmetry from each vertex to the midpoint of the opposite side. Do you remember what a vertex is? It's a corner. Do you see all these corners here? 7, 8. So it looks like there's going to be 8 lines of symmetry. A line of symmetry would go through here, I believe through here. I might be getting a little mixed up here, but so we can check 8 lines of symmetry from each vertex to the midpoint of the opposite. All right, problem number 16. Which quadrilaterals always have both line symmetry and rotational symmetry? The isosceles trapezoid, parallelogram, rhombus, or rectangle. Okay, here's a picture of these shapes. And you have to understand, line symmetry means it can be folded in half or in quarters, or however many ways you can fold it. And the opposite corners match. If the opposite corners meet up, then it is line symmetry. Okay, so here's a rhombus. We can fold it in half this way. And good to go. The rhombus has line symmetry. Okay, what about the parallelogram? Parallelogram looks like it could be folded in half and the corners meet, but they never do. I've always been boggled by this shape. It looks like they'll line up, but they never do. So the parallelogram does not have line symmetry. The rectangle, you can fold it this way, you can fold it this way. It has line symmetry. And then the isosceles trapezoid, it can be folded one way, giving it a line symmetry. It can be folded this way, but one way. So this one also has line symmetry. Now we have to identify, do these shapes have rotational symmetry? And rotational symmetry is where you take like a grid and you rotate this, starting in this isosceles trapezoid here. Try rotating it around, and if it ever matches up to this, the short side on the short base on top and the large base on top, then it would have rotational symmetry, which it never does. It doesn't match up here, it doesn't match up here, it doesn't match up here. It finally matches up when it gets back, makes a full 360 turn. So it does not have rotational symmetry. Whereas the rectangle, you'll start it here, it'll rotate, and then when it gets to the 180-degree turn, it matches. So it has rotational symmetry. The rectangle does. The parallelogram. Parallelogram didn't have line symmetry, so it was kind of out of the one of our options. But I wanted to show you that the parallelogram does have rotational symmetry, because when it gets here to this rotation, it matches what it was there. Do you see that? So the parallelogram does have rotational symmetry, but that's it. It does not have line symmetry. And then we have the rhombus. Rhombus had line symmetry, and it also has rotational symmetry, because when it gets to here, it matches the shape it was. Let's say it's like that. Yeah. So the only two shapes with both line and rotational were the rhombus and the rectangle. Parallelogram only had rotational, and isosceles trapezoid only had line symmetry. Okay. Problem number 17. A point located at negative 3, 7 undergoes 2 transformations. Its image is located at 3, negative 7. What were the transformations? So let's get some graph paper to look at this point on this paper. Okay, negative 3, 7 would be here, and 3, negative 7 would be here. It undergoes 2 transformations. Its image is located at 3, negative 7. What were the transformations? Was the point reflected over both axes? Okay, so to reflect over both axes, you have to understand this is the y-axis and this is the x-axis. Did it reflect over both? Okay, so to reflect over the y-axis, it would have had to gone 3, this 1, 2, 3 this way. And then how far is it from here? 7, 2, 3, 4, 5, 6, 7. Yep. So it would have to go 7 this way also. 1, 2, 3, 4, 5, 6, 7. So yes, it rotated over both axes. The point was translated right 6 units and reflected over the x-axis. Did it go right? Yes, it did go right 6 units. 6. And then it was reflected over this axis, the x-axis, to here. The point was translated left 6 units and up 14. Well, if we went left 6, we would be way over here somewhere. And then we have to go up 14, we'd be off the page. So no. And the point was reflected over the y-axis and translated up 14 units. Reflected over the y-axis. Reflected over the y-axis. And then go up 14? Yeah, we'd be way up here. So no on that one. That's a no also. Okay. Problem number 18. Point A, located at 3, negative 8, is translated left 5 units. What are the coordinates of A? So let's look at this paper again. Point A located at 3, negative 8. Okay, so it's really close to where we were. It's going to be right here. Point located at 3, negative 8 is translated left 5. So let's go left. 1, 2, 3, 4, 5. Where are we at when we get there? What are the coordinates of this? Okay, so the coordinates of this are negative 2, and then we're going to go down. So it's going to be another negative 1, 2, 3, 4, 5, 6, 7, 8. So negative 2, negative 8. Right here. Problem number 19. Point B located at negative 3, 5 is reflected over the y-axis. What are the coordinates of B? So we have to reflect negative 3, 5 over the axis. Let's do that real quick. Draw 2 lines. Find out where negative 3, 5 is. Negative 3, positive 5. Right here. And they're wanting it to reflect over the y-axis. Remember that this is your y-axis. Sorry. So to reflect it over this axis, we're going to have to go 1, 2, 3. Okay, so we moved 3 that way. Now we have to go the same distance, 3 this way. This would be a reflection over the y-axis, making this positive 1, 2, 3, and positive 1, 2, 3, 4, 5. So positive 3, 5 would be the answer. Positive 3, 5. Okay, and then last, select all that apply, describe the transformations. The yellow rhombus was translated up 5 units and then reflected over the y-axis. Start at one of the points on the rhombus and take it to see if it matches up with the blue rhombus when you're done. So let's take it up 5 units. 1, 2, 3, 4, 5. And then we have to reflect it over the y-axis. So we're going to go over 2 to get to the y-axis. That means we have to go over 2 on the other side of the y-axis. And sure enough, that's true. It did that. The yellow rhombus was translated right 4 units and reflected over the x-axis. So let's start at the same point and let's translate right 4. 1, 2, 3, 4. And then reflect that over the x-axis. So here we are. We're on a distance of 1 unit from the axis. So we're only going to go up 1 more right here. And no, it doesn't match up there. So it's not that one. The yellow rhombus was reflected over both axes. So if we were to reflect this over both axes, let's start here and go up 1. So to reflect this point over the x-axis would be here. Now we have to reflect it over the y-axis. So go over 1, 2, same distance on this side, 1, 2. We end up at this spot again. That is not on the blue rhombus, so that's a no. And then finally, the yellow rhombus was translated up 5 and right 4. Okay, so let's take this up 5. 1, 2, 3, 4, 5. And then we're going to go over 4. 1, 2, 3, 4. Yes, puts us right there. So, top and bottom. All right, that's it on the study guide 20 problems. And I hope you enjoyed this video.